আমরা কনগ্রুয়েন্স রিলেশন বিটুইন ইন্টিজার্স এই বিষয়টা নিয়ে ইন ডেপথ আলোচনা হবে। সো our first recall about congruence. It is introduced by Carl Friedrich Gauss. The congruence operation is introduced by Carl Friedrich Gauss. And this operation is basically the foundation of the modern theory of numbers. This is foundation of modern theory of numbers. Now we'll move to the definition. Here the congruence operation is symbolized as that symbol. So now we'll come to the definition of congruence. আমরা congruence এর definition দেব। So ধরে নিলাম let m is an positive integer n. You know n is basically set of all positive integers. Or we can write n as z plus. So that means it is 1, 2, 3, 4 and so on. This is called set of all positive integers. Then two integers a and b are said to be congruent modulo m. Two integers a and another integer b are said to be congruent modulo m if m divides a minus b. Symbolically, what we can write? Symbolically, we can write a is congruent to b modulo m, in bracket mod m, if and only a minus b is divisible by m. মানে a minus b টাকে আমরা m দিয়ে ডিভাইড করতে পারি। মানে m, if we divide a minus b by m, so the remainder will be 0. The quotient may be q, the remainder is 0. So that means here m divides a minus b. And that we can write in that way. A minus b equals to a multiple some integer k for some integer k. If we consider q equals to some k, in that case a minus b will be mk plus 0. So that means mk. So here important note a is congruent to b mod n. If I write n where a, b are integer and n is basically the positive integer z plus, if and only if a minus b equals to n multiple k for some n belongs to z. So as for example, we can say 4 is congruent to 1 mod 3. Why? Because since 3 divides 4 minus 1, that means 3. Or we can write 9 is congruent to 5 mod 2. Why? since 2 divides 9 minus 5, that means 4. But we can't say 3. 9 is congruent to 5, not 5. Why? Because since 5 is basically not divides, 9 minus 5, 4. Okay. So we'll use here the congruent symbol. B is congruent to B, that symbol is like this, and not congruent, যদি আমরা not congruent বলি তাহলে আমরা congruent লিখে এরকম কেটে দেব। But here another important note or observation, এখানে একটা important observation, if n equals to 1, then we can say A is congruent to B mod 1 for every integer M, A and B. That we can say. Because since 1 divides A minus B for all AB belongs to Z. This is quite obvious result. Now we'll come to some important properties. So property 1, every integer A is congruent to A itself mod M. So let M be a positive integer, then we can write A is congruent to A mod M for all A belongs to Z. Property 2, we can write if A is congruent to B mod M, that must imply B is congruent to A mod M. This is if and only. So first property is basically called reflexive. Second property we can say it is symmetric. And third property, if E is congruent to B modulo M and B is congruent to C modulo M, from that we can write E is congruent to C mod M. And this property is called the transitive property. Transitive property. So we can prove this property very easily. So কিভাবে এটাকে প্রমাণ করব যে what is given is congruent to B modulo M, and it is also given B is congruent to C modulo M. From that we can write M divides A minus B, and from that we can write M divides B minus C. So that means here we can write A minus B equals to M K1 and B minus C equals to M K2 for some K1 comma K2 belongs to Z. Now we add this to relation A minus B plus B minus C, that will be M K1 plus M K2. From that we can say A minus C equals to M K1 plus K2. That means M divides A minus C. Why? Because K1 integer, K2 integer, and sum of two integer is integer. So K1 belongs to Z, K2 belongs to Z. That implies K1 K2 belongs to Z. So that means here A is congruent to C modulo. So the transitive property is also true. So, if our relation is symmetric, reflexive and transitive, that relation is called equivalence relation. So here we can conclude the relation that is the congruence relation is an equivalence relation on Z. Now I come to another important definition of residue. A residue. এটা কিভাবে আমরা ডিফাইন করব? If A is congruent to B mod M, say let M is an positive integer and A comma B is an integer. If A is congruent to B mod M, then B is said to be residue. B is called residue of A modulo M. As for example, say 2024 is congruent to 1 mod 2023. That implies 1 is a residue of 2024 modulo 2023. That we can see. Now we'll come to next important concept. This is the residue class. So let A be an arbitrary integer and M is basically a positive integer. Then if we divide A by M, now the question is what are the remainders? So remainder may be 0, remainder may be 1, or remainder may be 2, or remainder may be M minus. So these are the possibilities. So here I am writing here, upon division by M, A leaves one and only one of the integer. One and only one of the integers 0, 1, 2 up to M minus 1. And the whole set of integers are, so here the whole set of integers is divided into M distinct and disjoint subsets. Divided into M distinct and disjoint subsets, and these are called the residue classes modulo. The residue classes modulo M, and it is denoted by 0 bar, 1 bar, 2 bar up to M minus 1 bar. Like here the 0 bar, this is also one class. We can write class 0 or you can write it in third bracket. That means if we divide an integer a, so here the remainder will be 0 always. So that will be 0 or plus minus m or plus minus 2m and so on. If we write class 1 or you can write in third bracket 1. This is considered class 1. So that means if we divide here a by m, the remainder is always 1. Okay. So that will be 1 or 1 plus minus m or 1 plus minus 2m and so on. In that way, the last one m minus 1, that will be class m minus 1 or we can say m minus 1. So this will be m minus 1 or m minus 1 plus minus m minus 1 plus minus 2m and so on. Now we'll come to the next important recall. If A is congruent to B mod M, then we can say A to the power n congruent to B to the power n mod M, or all n belongs to the natural number, positive number. So what is AB? AB are basically integer and M is positive integer. But here interesting fact is, but the converse is not true. The converse is not true. The thing is how to prove this result. So here A is congruent to B, so that result we can prove with the help of principle of mathematical induction. See here for n equals to 1, and obviously it is given A is congruent to B mod M. This is given. So the result is true. The result is true for n equals to 1. So now actually we are proving this result. We use the principle induction. We use the principle of mathematical induction. So now let us assume that the result is true. But the theorem is true for some positive integer k, for some positive integer k. So obviously then we can write a to the power k congruent to b to the power k mod m. So now what we have? We have the A is congruent to b mod m and a to the power k is congruent to b to the power k mod m. And what we know? We know the result. That is another important recall. What is the recall? If A is congruent to B mod M and C is congruent to D mod M, then what we can say? AC is congruent to BD mod M. So that means here we can write A to the power k congruent to B to the power k mod M. And from that we can easily write a to the power k plus 1 congruent to b to the power k plus 1 mod n. So therefore the result is true for n equals to k plus 1. If we assume it is true for n equals to k. So therefore, by the principle of mathematical induction we conclude that a to the power n is congruent to b to the power n modulo m for all n belongs to natural. So hence we prove this. What about the converse part? The converse part to true hobe ki hobe na? So obviously the converse is not true. So the second part of the question paper, the converse is not true. So you need to set up the counter example. You will see 9 square is congruent to 7 square mod 8. Why 9 square? That means 81 congruent to 49 mod 8. Why? Because since 8 divides 81 minus 49, that means 32. The remainder is 0. But 9 is not congruent to 7 mod 8. Why? Because since 8 does not divide 9 minus 7, that means 2. So that's why if we remove the power, then it may not be true. Similarly, there is another important recall. If x is congruent to ay mod m and a is prime to n and GCD of am equals to 1, then what we can say? We can say here x is congruent to y modulo m. But again, if, and the note, if GCD of am is not equals to 1, that means a and m are not prime, then ax congruent to ay modulo m does not imply x is congruent to y modulo m. If you need example, so you can say 3 multiple 2 that congruent to 3 multiple 4 mod 6. But if we remove 3 from both sides, that does not imply 2 is congruent to 4 mod 6. Why? Because since here GCD of 3 and 6 is 3, this is not equals to 1. So this result is only possible if A is prime to M, then this result is valid. Okay. Then the cancellation law holds, otherwise no. So now obviously we can solve some important problem. One problem is, okay, so we can write maybe the another result here. This is another recall. If D equals to GCD of AM and then x congruent to ay mod m, that implies if and only if x is congruent to y mod m by t, that we can see. And there is also another important recall. If x is congruent to y mod mi, where this holds basically for I equals to 1 to up to n. Here we can write if and only if x is congruent to y mod m. What is m? Where m is basically LCM of least common multiple of m1, m2 up to mn. That result is also true. Now we'll come to some important problem. আমরা কিছু problem solve করব. এই problem গুলো exam এর জন্য ভীষণ important. So here question 1. Find the least positive residue. Find the least positive residue of in 3 to the power 36 mod 77. So the least positive residue have another name. The name is called the remainder. So before solving this problem, we will recall some basic facts. The basic fact is the definition about remainder. Remainder is basically the least positive residue. Okay. So now we'll come to the solution of the problem. Solution. So first you will think about, okay, we'll divide 77 by 3 to the power 36. What will be the remainder? That we must know. But if we increase the power 3 to the power 1, 3, then 3 square, that will be 9, then 3 cube, that will be 27. And then 3 to the power 4, that will be 81. So it is very near to 77. So now we must see the gap. So 77 is here 81. So the gap is basically 4. So what we can write? We can write 3 to the power 4 congruent to 4 mod 77. That we can start. আমরা শুরু করব যে আমরা দেখব যে 77 এর কাছাকাছি 3 কোন পাওয়ারটা যাবে এবং সেই অনুযায়ী আমরা congruence অপারেশনটাকে অ্যাপ্লাই করব. Now okay, we can increase the power because আমরা 3 to the power 36 দরকার. So আমরা এই পাওয়ারটাকে ইনক্রিজ করলাম. So cube, again we have done the 4 cube mod 77. So what is formula we apply? We apply if A is congruent to B mod M, then A to the power n is obviously congruent to B to the power n mod n, and that whole for all n belongs to natural. Here our n is basically 3. So what do we get here? 3 to the power 12. This is congruent to 4 cube. 4 cube is basically 64. 4 cube means 64. So I need 77, mod 77. So I can do the minus 13 here. So that we can write minus 13 mod 77. Here we apply if A is congruent to B mod M and B is congruent to C mod M. So from that we can write A is congruent to C modulo M. That we can write. Again we will increase the power. We will increase the power 3 to the power 12, that whole square. That will be 169. If we increase the power, that will be 169 mod 77. Okay. Again both sides we are a to the power n, here congruent to b to the power n mod n, here n equals to 2. So now if we divide 169 by 77, so 2, so 4, so here the remainder is 5 and 1, 15 is the remainder. From that we can write 3 to the power 24, congruent 169 congruent to 15 mod 77. Okay, because 169 congruent to 15 mod 77. Now we just think about this is star and this is double star. So we just multiple is congruent to B, B is congruent to C, then AB is congruent to CD. So what we can write? Here we can write 3 to the power 12 multiple 3 to the power 24 congruent to. So 3 to the power 12 minus 13 and it has 15. So minus 13 15 modulo 77. Why? Because since if A is congruent to B mod M and C is congruent to D mod M, what we can write? AC is congruent to BD mod M. That we have used here. So what we get? We get here 3 to the power 36 is congruent to, so that value will be 15. So 13 multiple 15, 4, 4, so 195. So this will be minus 195. So that means the minus 13 multiple 15, that will be minus 195. And minus 195 is congruent to 36 mod 76. This is congruent to 36 mod 77. This is positive. So that means if we divide e to the power 36 by 77, so here after many steps this will be 36. There will be some quotient. So therefore this is the least positive, 36 less than 77 and is also positive. So the least positive residue in 3 to the power 36 mod 77 is 36. Okay, or you can write the remainder. Now we will come to next important problem. Question number 2. This problem is very, very important. Prove that 19 to the power 20 is congruent to 1 mod 181. So how to solve this problem? So okay, if we do 19 square, that means 19 multiple 19, and that value will be so so 361. So this value is basically 361. So if we divide by 181, so 19 square is 361. So 361 if we divide by 181, 2 times, that will be 362. So minus 1. So that is congruent to minus 1 mod 181. Now we'll squaring on both sides. So 19 square we need 20 power, so we'll square not squaring, we'll taking the power 10 on both sides. It will be minus 1 whole to the power 10 mod 181. So that means we apply if A is congruent to B, আমরা এটা apply করলাম যে mod m যদি হয় তাহলে that implies A to the power n congruent to B to the power n mod m for all n belongs to natural number. And here our n equals to 10 and this is also natural number. So that means what we get? We get here 19 to the power 20 minus 1 to the power 10 is 1 mod 181. So proved. Okay, so this is quite simple problem. There is another interesting problem. So number 3 very important. Find the remainder. Find the remainder. ভাগশেষটা তোমাকে দেখাতে হবে. Find the remainder when 1 factorial plus 2 factorial plus 150 factorial. This factorial is divided by 15. Is divided by 15. Okay, that means এখানে আমাদের যেটা জিজ্ঞাসা করা হলো যে 1 factorial 2 factorial plus 50 factorial এই যে নাম্বারটা একে যদি 15 দিয়ে ভাগ করি তাহলে ভাগশেষ কি হবে, রিমাইন্ডার কি হবে, এটাই আমাদের কোশ্চেন। সো আমরা দেখি প্রথমে 1 factorial 2 factorial up to 50 factorial করে কত হয় solution. Okay, so if I think about 15 means 5 multiple 3. And again if it starts from 5 factorial, so 5 multiple 4 plus 3 into 2 into 1. So you will see 5. So if we think about 6 factorial, so 6, 5, 4, 3, 2, 1. Therefore, eখানেও 5 and 3. So that means what we conclude? We conclude here, so we have the 5 factorial is congruent to 0 mod 15 because 15 is a factor here, 3 multiple 5. Similarly 6 factorial, similarly 7 factorial, and we can write also 5 plus n factorial. This is congruent to 0 mod 15 for any positive integer n, for all n belongs to natural number. That means 5 factorial, 6 factorial, 5 factorial congruent to 0, 6 factorial congruent to 0, dot, modulo 15. Okay. So therefore, what we can write 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 6 factorial, plus up to 50 factorial. So that we can write, that is congruent to 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial, and balance part will be 0. So that is mod 15. Why we are using star and double star? So by star and double star, কারণ 5 factorial পদ থেকে যদি 15 দিয়ে ডিভাইড করি that will be 0. So now what is this value? 1 factorial. So 1 factorial, that means 1, 2 factorial means 2, 3 factorial means 3 multiple 2. So that will be 6. 4 factorial, that means 4 multiple 3 will 1, that means 24. So 1 plus 2 plus 6 plus 24 mod 15. That is congruent to 33 mod 15. Now if we divide 33 by 15, what will be the remainder? The remainder will be 3. This is congruent to 3 mod 15. Mod 15. So that means what we get? Therefore, we get 1 factorial, 2 factorial, 3 factorial, up to 50 factorial. Okay. This is congruent to ultimately 3 mod 15. So thus the remainder, when 1 factorial plus 2 factorial plus 50 factorial is divided by 15 is the remainder is 3. Now you have asked the question like this. Question, find the remainder when 1 factorial, 2 factorial up to 2024 factorial is divided by 15. So with the same logic, your answer will be again 3. Because after 5 factorial, all are basically 0 if you divide by 15, because 15 is a factor. Okay, so the question may be MCQ type. The remainder when 1 factorial, 2 factorial, 3 factorial up to 50 factorial is divided by 15 is option is 0, option B 1, option C 2, and option D 3. So option D is the correct option. Or you can ask the question, the remainder when 3 to the power 36 is divided by 77 is option A 0, option B 3, option C 36, and option D 41. So 36 is the answer. In that way you have asked the question. তোমাকে এভাবে one option correct question জিজ্ঞাসা করতেই পারি. Now we'll come to one important concept. This is the linear congruence. So next we recall about linear congruence. What is the definition of linear congruence? A polynomial congruence of degree 1 is called a linear congruence. It's called a linear congruence. Now the question is, what is the general form? Question, what is the general form of a linear congruence? So the general form of linear congruence, answer, the general form of a linear congruence is linear congruence modulo m, where m is basically positive integer, is x congruent to b mod m, where A is not congruent to 0, A is not divisible by M. So this is the general form of a linear congruence. So as for example, 7x is congruent to 2 mod 5. Okay. So the observation is 7 is not congruent to 0 mod 5. So this is an example of a linear congruence. Now the question is যে আমরা একটা linear congruence কে কিভাবে solve করব? কিভাবে দেখব একটা linear congruence এর number of solution, it has unique solution or not, but how to solve a linear congruence. So there is a theorem. The theorem is you have a linear congruence. So just to think, you have a linear congruence, A is congruent to B modulo M. So that flow chart is very, very important for solution. So where A is not congruent to 0 mod M. How to solve? You will calculate GCD. So first you will calculate GCD of A and M. GCD of A and M. That you will calculate. So there will be the cases. The GCD of A may be 1. GCD of A means the coefficient of x, and M is basically here A, B are integer and M is positive integer. So the first case is the GCD of AM is 1, or the GCD of AM may be some D, and D is basically greater than 1. There are two cases. GCD 1 হতে পারে, আবার 1 এর থেকে বড় হতে পারে. If GCD is 1, then we conclude something here. We conclude the unique solution. Here unique solution. So here our conclusion is the linear congruence. In that case, the linear congruence X congruent to B mod M has unique solution. Whereas if the GCD of M is basically D, so we'll do two things. One is D divides B or not. This is our B. D divides B, or second is D does not divide B. If D divides B, then the linear congruence has D incongruent solution. And it has D incongruent solution. And if D does not divide B, so that means this case is for no solution. So here the conclusion is the linear congruence has D incongruent distinct solution in Z, and here the no solution. So no solution, D incongruent solution, and unique solution. So these are the three cases here. Okay. So now we'll solve here the problem. We'll solve one important problem. Question 1. Solve the linear congruence. Solve the linear congruence 5x congruent to 3 mod 11 mod 11 এটা আমরা কিভাবে সলভ করব না solution. So this is basically linear congruence. So the given linear congruence is 5x congruent to 3 mod 11. So we calculate. So here we just compare with ax congruent to b mod m. So what he will do, he will calculate GCD of a and m. Since GCD of a means 5, m means 11, so this is 1. GCD is 1, it has a conclusion unique solution. Unique. So the linear congruence, this is 1, the linear congruence 1 has unique solution. Okay. So that means the solution exists and the solution will be unique. আমরা solution থাকবে এটা শিওর হয়ে গেল এবং কটা থাকবে exactly একটাই থাকবে. Now we'll come to the theory. Since now we'll how to solve. Now since GCD of 5 and 11 equals to 1, that implies there exist unique integers. There exist integers u comma v belongs to z such that au plus bv, so 5u plus 11b equals to 1. Because you just recall the fact that GCD of ab যদি 1 হয়, if and only if there exists uv integer such that au plus bv equals to 1. So 5u plus 11b, that will be 1. Now you will solve with the help of Euclid algorithm. So here you just think about your u will be minus 2 and v will be 1. You just do it simply. You just check u1. You just check. Put u1, v1, u2, v1, u1, v2, or u minus 2, v1, u1, v2. So in that way you can check. The simple checking, and you will see u equals to minus 2 and v equals to 1. So এটাকে আমরা কিভাবে লিখতে পারবো? Therefore 5u, so 5 into minus 2 plus 11v, v is basically 1. That is basically 1. Okay. But okay, we'll divide by 11, mod 11 on both sides. So from that what we can write, that implies 5 into minus 2, and if you divide 11 that will be 0. So congruent to 1 mod 11. So just you compare with 5x congruent to 3 mod 11. So I need 3 on that side, right side. So we can write from here. I need 3 here. So that will be multiple. So that will be 5, and here multiple by 3. That will be minus 6 mod 11. So here the solution is x is congruent to minus 6. So x equals to minus 6 is the solution. So hence we can write x equals to minus 6 is the solution. So all solution are x is congruent to minus 6 mod 11, and that we can write, that is x is congruent to 5 mod 11. Why? Because since minus is congruent to 5 mod 11. Okay. So thus all solution are congruent to 5 mod 11, and therefore and hence the given linear congruence as unique solution. Thank you so much.